Okay, let's go through some basics. If we have something like log AB, and I'm just going to walk you through some of the basic rules that you would have learned in Pre-Calc 12, but maybe you haven't. So just a few things. If we want to rewrite this, we can separate this log AB, and you'll see the similarities. I want you to think of the similarities with exponent laws as we're going through this. Another way that I could say this is the same thing as log A plus log B. Remember with exponent laws how this sort of resembles the first exponent law that you went through? So keep that in mind as we're going through this, because I think viewing it from a familiar perspective makes things a little bit easier. So if we have log A over B, what do you think that rule is going to be? Good. Log A minus log B. So far, so good? Okay. So then if we have something like log A of X, I'm using variables, but of course I could have, kind of like yesterday or last day, we did log base of 5 of 25, for example. What would that be? Log base 5 of 25, what's the answer? 2. Good, right? We're just sort of switching back and forth between exponential form. So I could substitute in a 2 there. The point is, this is called the change of base rule. If I have anything written like this is the same thing as me saying log base B. So like, you know how I said it might have been 2? I could change that to log base 5. Of X over log base B of A. Let me explain what just happened there. You know what's happening? I stopped using my colors, and that's confusing. So there's the A there, and for the X that was here, that went to the top. So basically what I'm saying is, if I have some logarithm that isn't base 10, let me explain what I mean by that. Like, let's say I had something that says log 7, and you don't see a number written at the bottom for the base. We assume that that is base 10. So if you see log 7 or log 5 or log 130, the base is 10 in that case. We just don't write it. Good? So if it's not base 10, so if I have like this A has some other number there, I'm allowed to change it to any base that I want. The rule is, though, that I keep the base the same at the top and the bottom. So this is like a tool or a trick that we can use to be able to help us to simplify and cross things off. Does that make sense so far? And it'll make more sense when I give you some actual examples with numbers, so stay tuned, we will get to that. But for now, I guess we're sort of memorizing or getting to know these. Lucas, you have a question? So B is any number that we pick. I'm going to show you with an example so that I can clear this up right away. Let's say I had log base 5 of 2. According to this change of base rule, like this rule that we just went through right here, I can rewrite this to say log 2 at the top over log 5 at the bottom, but I could put whatever number I want there. Like maybe it's convenient or helpful for me to change them to base 7, because maybe there's other stuff in my equation that has log base 7 and I'm trying to get them in similar terms. Or I could leave it without anything written there, which would just be base 10. So what I'm saying is that like little A at the bottom, I could plug in whatever I want there. I could get rid of that. I could call this 3. I could call that 3. The rule is I've got to keep it the same top and bottom. I could get rid of it totally and just leave it base 10, and that's also okay. Do we get that rule and see how that comes up? So it's another strategy or tip or rule that we use to be able to cross things off or simplify or to make it easier, basically. So far so good? On to the next one. If we have log base A of B, ready for this? That's the same thing as 1, oh, that's the wrong color. Sorry, everybody. 1 over log base B of A. Whoa. Do you see what just happened? We swap the base, and if we're writing it as the reciprocal, then these two just swap. So again, this is a tip or trick or rule that can be helpful. I'm not going to lie to you. We could do all this stuff without knowing this. I'm throwing in like an extra lesson that I don't normally do. Well, because of, if you did the 10-week crash course because of the pandemic last year, or if you didn't do Pre-Calc 12 at all, here's a little bonus or preview. Good? So if you're struggling or feeling out of it, which no offense, some of you are looking like that, don't worry too much. Don't stress about this too much. It's next week we're going to get into the derivatives of this stuff, and that stuff does matter a lot. I'm not saying this doesn't matter. I'm just saying this is bonus or extra. Good? Okay, so there's a few of them to start off with. Here's another one. If I have log base A of A, so I have the same thing for the base and here. That's just equal to 1. And you can logically think your way through this. If you switch that to exponential form, do you see how this logically makes sense? Right? Because it's saying a to the power of 1 equals a, and we know that that's true. So anytime you see the same thing here and here, you know that it can cancel out and it just equals the number 1. Also a helpful tool that we'll use and we'll manipulate our equations to try to get to that. Because the goal is always look for similarities, simplify, cancel things out. Right? One last thing, and then we're going to call it a day. Not really, but at least for this part. Log base E. Do you know what that little symbol E is? Euler's number? I don't know. I think I even taught the grade 10s just because one day. You may not have ever have seen it before, but let's say we have this of 7. Log base E, we call that ln, and this is the symbol for it, like ln, and I would call this ln of 7. On your calculator, you actually have a ln button. So it is still log, but instead of base 10, it's base E. E is the symbol kind of like pi. That's called Euler's number. It's an irrational number. The digits don't repeat. They keep changing. And that's about all that you need to know about that for now.